to ask Carl to start the recording, and he's ahead of me, so he already did. And then I'll just briefly present Dimitris Tsomokos, who will present for us today on embodied personality and active inference. Presentation, then round of questions, and finally a summary by Carl. Thank you, and looking forward to the talk.
Thank you very much indeed, Peter, and thank you, Carl, and the whole team. I feel very, very privileged by sort of the generosity, your time. So I'm going to keep it as sort of straight and 30 minutes as possible, because obviously there are many things that can be said. Active inference lends itself naturally to a million different paths that one can take, and my personal interests are varied. So I want to keep it as focused as possible. And yes, thank you very much indeed for having me. It's a great pleasure. And I'll just start by saying that this is empirical work. So the beginning sort of or the core of the presentation is centered around these empirical findings. But I will also, as I say, use these for further thoughts and hopefully the formulation of some hypotheses in terms of active inference or FEP-AI. And as I was saying before to Peter, it's incredibly, well, humbling, but also makes me quite nervous with the incredible expertise, obviously, here in this virtual room. So I'll use that to my advantage in the sense that please cut in and let me know when, something can be said very differently, or there's potentially a path that I'm taking wrong turn. Please do so. That's it. I'll just go straight in. Perhaps I want in one slide to give the whole background, aims, and kind of the main result from the beginning, and then go deeper. And I think I can afford to do this, as I said, given the expertise in this room. So I'm making a lot of assumptions on the audience, obviously, but I think it's warranted in this case. So jumping straight in, cybernetic big five theory of personality. That's the main thing I'm going to be talking about. And within the CB5T, so cybernetic big five theory of personality, what I will talk about will culminate in talking about stability versus plasticity, which seems to be the most fundamental or basic way of looking at personality, because obviously there are many, many ways of looking at personality, and stability versus plasticity seems to be the most fundamental way. And the key in cybernetic big five theory is that personality is seen through the lens of goal-directed behavior in human agents. Right, so that's the first big thing. The second big thing is FEP-AI that I think I can skip over. And then the newest perhaps thing here is bring these two theories together. That's something I was sort of thinking about recently, then looked at the literature, and then I found that Saffron and de Young have addressed this. So de Young is obviously the cybernetic big five theory originator, and then a couple of authors there did sort of try to bridge cybernetic big five theory with the free energy principle, and the bridging happens in various ways. I'll briefly sketch them, but stability and plasticity seem to be the main anchor, or for me at least, that seems to be the clear lens through which to approach bridging the two theories together. And you can see, I'll dive into that a little bit more, but in a nutshell, stability is all about protecting the goal-oriented behavior from distractions and disruptions, and therefore it keeps epistemic foraging to a minimum so that the goal-directed behavior can be pursued, the specific goal-directed behavior in the moment. Plasticity, on the other hand, can sacrifice the goal directed behavior in the particular path or strategy in favor of more epistemic foraging. And then out of that, so I superimpose some empirical findings on that, and they have to do with the first research question, which is where I started from, which is, are these basic dimensions of personality grounded in motor function, fine and gross motor skills in infants? So put simply, can infant psychomotor functioning, fine motor skills, gross motor skills, and communicative function, can they predict stability and plasticity and personality, other personality dimensions, and cognitive dimensions later in life developmentally? But then out of that, you have the broader question, which, well, what is personality in terms of FEP AI? So clearly, not all organisms, I mean, I'm talking from a cell to a human, and their interactions in an ecosystem, they don't react the same way to epistemic, to affordances, and to, the curiosity levels are different, reactions to threat and danger are different, and so on. So how do we formulate hypotheses and test that? And I've sort of mentioned that in this sense here. How do different organisms tend to deal with prediction errors or surprise in different ways? So is that what personality is in terms of FEP AI? That's another broader question. Okay, so first of all, what is known already? What is already known and has been hypothesized in that link between CB5T and active inference? So a quick review of cybernetic big five theory. There are two big sort of categories: the personality traits and the characteristic adaptations. And de Young claims that these are the only two things you need. And I see no reason to dispute that. That makes complete sense. Personality traits are, of course, those relatively stable patterns of emotion, motivation, cognition, behavior, and so on over time. And I like how these are quotes, by the way, from the original paper. So these are not my interpretations, they're verbatim. So I like here the evolutionary perspective being brought in, because, of course, through the long time scales of evolution, these have been certain tendencies of emotion, motivation, cognition have been mapped out, let's say, internally. So therefore, that's sort of the approach of personality traits, the definition rather. Characteristic adaptations are stable goals, interpretations, and strategies that have to do with the individual's or organism's particular circumstances. So they can shift. I mean, what would get someone out of bed? That would be a characteristic adaptation, obviously. The way they get out of bed, are they motivated? Are they, or whatever, grumpy like me, or that those are traits. But the characteristic adaptations, I guess the why, in a sense, is that part of the theory. But they are relatively stable. And goals and strategies have I think, a pretty direct mapping onto FEP AI. But I really like that word. That's from the 2015 paper, interpretations, because I think that then speaks to the to generative models in one sense, and then going back to, in psychology, internal working models that go all the way back to things like attachment and so on. Okay, now this is sort of the broad view of how the whole sort of hierarchy of personality can be mapped in this framework. And the evidence on this stuff, by the way, is quite astonishing. I mean, the middle layer, the big five, so neuroticism, agreeableness, conscientiousness, extroversion, and openness, intellect. I mean, that goes back, decades. And and then and so do the aspects below them, and then we have the facets. So each of the big five is broken down into two. So, for example, agreeableness has the compassion element and the politeness element. And as I said, so these words, from a physicist point of view, one can always ask, well, what's the correspondence of those things here to the real thing? I mean, we're using a word like compassion or politeness. What does it even mean? And so it's important to remember these are stand-ins. These are proxies, words that are proxies for whatever the real thing is, the stable pattern of behavior. And I think there is a bit of correspondence in that with actual sort of the hard sciences and physics, because at the end of the day, you can always ask, well, what's a quantum of energy? What is an electron? I mean, we can see trajectories. You know, there's always a deeper question of what is it really? So when I first came across these things many years ago, I kind of dismissed them as in a little bit of, well, okay, I mean, there are five big dimensions of personality. Maybe there are six, and there is the hexaco model with six of them. So, but it turns out they're pretty coherent and stable. So, yeah. So my confidence in these things has grown a lot as I've studied them more and more. So then, with pretty strong statistical methodologies, these have been put in this hierarchical way, and then they end up factoring into stability and plasticity. So stability is the negative. That's why there's the minus there, negative of neuroticism. So low neuroticism, high agreeableness and conscientiousness. So somebody, I mean, just quickly to paint a picture of someone. So somebody who is highly in conscientiousness, detailed, oriented in terms of pursuing a goal and thinking of other people, the team in pursuing that goal, and generally pro-social and low in neuroticism, for example, well, that is a pretty stable organism or human agent. And versus plasticity, for example, which may sacrifice maybe a little bit of prosociality or maybe a bit more neurotic, but then again, more exploratory. Okay, so that's the general idea, and we're focusing on this upper level. So at least for my empirical findings, this is the level I'm focusing on. And in terms of cybernetic big five theory, what you have is a function for each of these levels and each of these aspects, traits and meta traits. And it's very, very interesting stuff. So, for example, if you look at openness, intellect, that's the cognitive exploration and engagement with information, for example. So curiosity. Intellect is in other, here it is, intellect as an aspect. It's detection of logical or causal patterns. So I think there are whole loads of mappings here between the two theories that have been identified in that 2021 paper. But if you look at stability and plasticity, is what I said earlier. In the case of stability, you have protection of goals, interpretation, and strategies, whereas in plasticity, you have more exploration, creation of new goals, interpretation of strategies. So now here's where things get tricky for me, because I don't have the expertise to deal with these. So what I'm going to do here is just sketch very briefly the ideas presented in Saffron and de Young. So maybe mispronouncing the name there, but that's, I think this picture here seems to be the main one. I believe it is a model, a proposed, hypothesized model of a human organism, of a personality. And the eventual mapping, I mean, they go through each of the big five, hypotheses for each of the big five traits. But focusing on the meta traits, which is what I want to get to, they write here, within FEP-AI, stability would have its closest correspondence with optimization for the pragmatic value of minimizing prediction error with respect to achieving particular goals. So they map that onto precision over the seam matrix, so priors over outcomes. Whereas plasticity is optimizing for the intrinsic epistemic value of information, and they map that onto precision over policies, so the beta and the gamma parameter here. So, as I said, I cannot judge the sort of the precision of this or the validity or the value of this correspondence here, but that's what they have proposed. Now, taking a step back and then again looking at the empirical findings. So all of this is known. So I've just described the sketched out the lay of the land, let's say, and the empirical findings that I propose to use as hypothesis generators here are the following. So the question I dealt with was, do cognitive functions in, say, middle childhood, 5-7 years old, and then personality, because we know cognition and personality is very much related. There was a PNAS paper that mapped out something like 178 cognitive functions in adults, of course, 2 personality traits. So does cognition and personality in childhood and late adolescence, so this is age 17, are they predicted but by early psychomotor function? So gross motor activity skills, fine motor skills, and communication. So just quickly, though, because just for the sake of completeness, I want to say, where does this data come from? So just I'm brushing aside so much detail here because, as I said, I know that I can sort of trust the expertise of this group, and you'll also have to trust me a little bit that that these findings are solid and that I've taken into account and care of many of these details. So where do the data come from? Well, the Millennium Cohort Study is one of the UK's, and in fact UCL's major cohort longitudinal studies, which is quite incredible. I mean, something like 19,200 or so. So over 19,000 families participating in the study. It started at around about 2000 to 2001 for most children. So we can consider them roughly equal age. They have a couple of months difference, but I actually account for that. So started 2000, and then there were waves at age 9 months, and then 3 years, 5 years, 7 years, and so on. We're waiting for this one at 23. So the latest available was 19. So 19,000 families, around about 10,000 or so, and have sort of good data, complete data without attrition and dropping out of the study by age 17. And it's quite incredible in terms of all the very consistent measures and the way they were taken and so on. So that's where this data comes from. And this is the sort of sketch of how I addressed the research question. At age 9 months, the primary caregiver, and there was also a home visitor, assessed the child's motor function. For example, gross motor function, can they stand up? Can they maybe do a step? Can they grab themselves? Can they grab someone's a toy that's given to them with a whole hand, a palmar grip? Fine motor, on the other hand, is finger and thumb, the pincer grip, and so on. There are different ways that we measure these. Communication is smiling back and so on, pointing. So those are very consistently measured. And then, of course, at age 17, we have the big 5 personality traits. So this is a self-reported questionnaire. And then in the middle there are also these measures. So theory of mind, that's false belief understanding, measured with a classic Salian test, which I won't go into. As I said, you've got to trust me that these were measured and available. Prosociality, that was reported by the primary caregiver and in another way by the teacher. These are 5 items from the SDQ, Strengths and Difficulties Questionnaire Scale. Again, very well validated, very well known measure. And then cognitive ability and self-regulation, both of these are latent variables in my model because cognitive ability has 2, has verbal ability at age 5 and non-verbal, so spatial ability. And self-regulation is a latent variable because it's made out of emotional regulation and independent skills. So again, very well validated measures. So that's the broad model addressing the question, do infant psychomotor functions predict personality? And what is the role of cognition in the middle of that? So that's very technically sort of important, the pathways in the middle, the mediators, for a whole load of stuff. So I'm working with now Institute of Education folks, Irene Fleury's team at the Cubic Lab, and going to be doing work with them as well. So for us, these measures are very important. But I'm going to clear out, for the purposes of the results, really, the middle bit and focus on the psychomotor function to personality. So a final note here. When I say no adjustment, the core model, I mean that this is exactly what I showed, that main model, here. When I apply adjustments, what I mean is that in the structural equation model, I control for a lot of covariates or potential confounders. So these include the exact age, well, in months of the child, the mother's age, because we're talking about motor functions at age 9 in infancy. So we know these things can be important. So infant age in months, mother's age, income, this is equivalized OECD income for the whole family, socioeconomic status as in maternal education and the neighborhood. So the neighborhood can play a role. So for example, disadvantaged in England, advantaged in Wales, advantaged in Scotland, and so on. So this is all 4 countries of the UK. And then other important measures that we know play a role in these associations. So when I say fully adjusted model, I mean that all of these confounders have been taken into account, and the good thing is that the results still stand. So it's not like these results are actually due to one of the confounders, say socioeconomic status or mother's age or education, and so on. I actually have confounders down to the level of perinatal outcomes. So I have small for gestational age, which is a very important thing. Obviously, if you are born early or you're born underweight, then we know that these things can affect fine or gross motor function and cognition later on. Okay, so actually, I'll skip over the cognitive bit. I don't think it's that important. But you can see that there are various associations, relationships here. Blue is positive, red is negative. So obviously you have things like self-regulation. The more self-regulated you are, the less neurotic you are. So some of these things are very straightforward and make perfect sense. And some of them, a few of them, we actually know already. So it's repeating what is known in the literature. So fully adjusted model with all those confounders, most of the results and certainly the main results stay the same. But this is the one, no, this is the one that I want to focus on. And first of all, address the nitty-gritty statistics of it, that some, in these cohort studies, sometimes the criticism is that the effect sizes are small. So this is standardized coefficient, and you see values of around 0.05, for the relationships of interest. There are other ones like self-regulation and neuroticism or theory of mind, and another one that are much bigger, more in the moderate to strong size. But for cohort, but these would be considered small. If you taking certain considerations into account, the fact that it is many, many years that we're talking about, like 16 years later and so on, you could call them small to moderate, but they're definitely not big effects. But of course, in a cohort study, you also expect that, right? Because we're talking about 10,000 families here, 10,000 children. And, a small effect in a very large population is still sort of, can be significant or rather important, let's say. So putting that aside, these are the significant associations, and abstracting them out to those meta traits at the highest level, we find essentially gross motor function predicts plasticity, fine motor function predicts stability. So there's kind of a discriminant validity there, if you want, between the motor functions and the two dimensions, the meta traits of personality. Communication predicts both and equally. And that, I think, is for me the main result, or starts the generation of hypotheses there. Because if for cybernetic big five you have plasticity being more exploratory, expressing the personality dimension of exploration, the tendency to be more curious and look for more information out in the world, act in the world to get a lot more information back. Whereas stability expresses the tendency to maybe not act on the world so much, not gain as much information, but really be updating the models while working in a. I heard back what I said now. Obviously, you do need to act on the world to update the models, but keep stable in the goal without distractions, without major changes to the generative model, rather. So if those two are the main dimensions, then it looks like they have a mapping in terms of the motor functions being delineated like that. So gross motor function being more supportive of the plasticity aspect or meta trait, whereas fine motor function being more supportive of the stability meta trait. Yes, I think I'll stop here, and thank you for listening, and yeah, use this as perhaps as a starting point for those research questions.
Thank you very much, Dimitris. This is really exciting. Before going on to discussions and questions, we will just briefly unmute and give Dimitris a round of applause for the presentation.
Thank you. Thank you.
Okay, thank you. I'll moderate questions and comments. So if anyone has questions or comments, just raise their hand or write in the chat. I'll keep an eye on that as well. And of course, usually people just need a few minutes to
Sure.
Gather their thoughts and find the long list of questions. But I have one maybe to start with, which is, how do you think we can be of the most assistance to you specifically, if that makes sense?
Yeah, absolutely.
It's good for framing the rest of the discussion.
Yeah. Well, as I said, I think number one, does the Saffron and the Young, if I'm pronouncing right, paper make sense? I'm not asking details or to judge it, but is it a good starting point? You know what I mean? And two, is there approach, because they're using some toy toy models that are available, I believe mostly MATLAB, in MATLAB, not, but maybe R as well. But are some of these models conducive to testing out these things? Yeah, that's mainly it, I think.
Okay, Then I will maybe.
Oh, sorry, there is a third thing.
Yes, of
There
course.
is a third thing, which is for me actually the one, the big one.
Okay.
So one of the reasons why I went down the road of fine and gross motor skills is because I have seen associations in the past that are intriguing for me,
Mm.
but I
Mm.
don't have the knowledge to pursue. So we did actually one piece of work with Irini on social theory of mind and attention, and theory of mind and strategies in dealing with risk. What we essentially, what I looked at was that the same brain regions that have to do with theory of mind, temporoparietal junction and a couple of others, are the ones that are actually responsible for shifting attention quickly, especially in social stimuli.
Mm.
So I thought, well, if that's the case, then potentially there is that neural correlate points to the fact that in children, if they have more theory of mind, perhaps they are better at dealing with quick updating of their strategies in risk taking and risk taking behaviors. And we have that measure at age 14. And lo and behold, we found that this is the case empirically. So
Mm.
I'm wondering if it is a valid approach in neuroscience to say, well, if a brain region neural correlates point to two things, for example, theory of mind and attention, maybe there is, some connection there. So, and in that sense, I was thinking, well, if fine and gross motor skills have distinct brain areas, or
Mm.
some brain areas are distinct, then does that, and then how does that actually relate? And then I came across this from uh, one of Carl's papers
Mm.
on this area that I won't even try to pronounce, like a rock band of some kind. And then I found that there is actually some aspects of it that affect fine and gross motor skills. So that's the third thing. Is there some kind of delineation between fine and gross motor skills in the brain that could potentially then generalize to the way we tend to deal with surprise and therefore map onto this personality stuff?
Okay, so the original paper, the fine and gross motor skills question, and
Yeah.
the second one you said
The
was
second one was related to the
the
paper in the
software.
sense the toy models. Can we use
Yes.
a toy model to map out these things? Yeah, yeah.
Okay. I will have some thoughts that I can bring that may or may not be useful, but I
Mhm.
see that first Jerry has a question or a comment.
Yeah, thanks so much. Oh, it looks like my video was kind of dark there for a second. Apologies. Fascinating stuff, first off. So very interesting. I appreciate you bringing it here.
Thank you.
Something that was coming to mind was some research I remember reading about in sports, for instance, that those who are kind of older within their age group tend to be the ones that then get the most play time basically, or are the ones that are, put in those roles to be within that sport in the first place. So you tend to have a lot of people that are older within that. And just because of the difference in fine and gross motor skills, just by months, even at those younger ages. And I was curious if that's something that was part of your research, if it was something that was considered, because it was just making me think about some of our cultural
Yeah.
decisions there, like that, we sense these either fine motor skills or gross motor skills, and we almost sort them culturally early on. And does that have some sort of effect?
Yeah, that's a great question. And there are two parts of it. The second part, the relationship with the sort of cultural dimension of this, for example, in the nursery school, indeed, that's exactly what happens. The teachers would sort of implicitly make implicit judgments on these skills and therefore steer children one way or another. So that's perfect. To that, that's a very, correct observation. To that, I don't know the answer. I didn't take it into account. On the basis of the data, I don't think I could. But the first part, though, is I think the more easy to answer, or I see it as a first part, and technically it's easy, which is, normally it's the other way around. We're looking at, in pediatric assessments are going to look at milestones, and they're going to say, who has a delay in fine motor skills or gross motor skills. So they're going to go through the checklist and they're going to say, well, you're now 9 months. We expect this level of fine motor skills. You're below, you have a delay. That's the traditional way of looking at it. However, the MCS, the Millennium Cohort Study data allows us, because it's a birth cohort study, it allows us to invert that question and to say, at age 9 months, plus minus 1 month, and I've taken that into account, at age 9 months, just map the level of fine and gross motor skills. No delays, just the level. So somebody could be, at level 10, somebody at level 7. And that's the correlation I'm looking at. Well, semi-causally, in the SEM framework. So that's the correlation. I'm saying higher fine motor skills predict more stability. Higher at age 9 plus gross predict more plasticity.
Okay, awesome. Thank you so much. That explains a lot.
Thank you, Jerry. Then I have a comment or two.
Mm-hmm.
One thing was just on the software, that
Yeah.
there is mainly the software is in MATLAB, but
Okay.
there is also a Python package
That
called,
converts. Yeah.
called PyMDP,
Yeah.
which Heinz made. And there is actually, but this is not done yet or full test or anything, but some people are making software in Julia as well.
Mm-hmm. Okay.
And one way to use these softwares is indeed to run simulations or toy simulations where you instantiate agents and you change the parameters and you look at how the behavior would be different in different environments and with different parameter settings.
Yeah.
And without having read the Safran and de Jong's paper, it sounded like that's what they were doing. So identifying specific parameters that you change, and then you get, for example, more exploratory behavior or.
Well, so I just quickly on that, I think it was more of a theoretical paper, if my reading is right. So what I mean is they're drawing potential linkages between the A matrix, the B matrix, and saying, well, for example, the B matrix is something like how do I believe things are likely to change, and so on and so forth. And the only simulation I have seen seems to me to be simply, there is a simulation, sorry, here, but it seems to me that it is a sort of showing how it could be done, but it's kind of out of the box of what is there. Illustrated pre-packaged, with SM12. Yeah, so I don't think they actually played around with all the parameters, which is fair enough. I mean, they just put out what can be done. Yeah.
Yes, so I think with the challenge with toy simulations is, of course, using them to link to the big 5 traits is, of course, that for the simulated agents, you don't have big 5 personality scores.
That's right.
But you can maybe find something analogous to that, I would imagine. Certainly, I think you can find something akin to a stability or plasticity. I have a thought on that, which I will get back to just in a second.
Okay.
But just to say that one other option is to do computational fingerprinting, as they do in computational psychiatry.
Okay.
Where what you essentially do is you let participants in your experiments do some task, and you take one of these simulated models, but then you find the parameter values for that model that would make it the most similar to what the participant has been doing. And so you get a guess at the specific parameter values that this participant had based on the behavior in the experiment. And these you can then correlate, for example, with the big 5 personality scores.
Okay.
And that there is, I can send you this later, but there is a step-by-step tutorial on how to do this kind of parameter estimation with these active inference models, one of which you're showing currently here.
Okay.
So I don't know if that's interesting or not, but that's certainly one way one could go at it, which would fit in the computational psychiatry field and literature and paradigm, indeed.
Yeah, brilliant. Yeah.
Yes, the other thing before I see Patrice has a question, so I will just do one more comment, is that the balance between stability and plasticity, so between not being changed too much and not changing too little, depending on my environment. I think this is really interesting, and interesting that it fits the big five so naturally. I was not aware of this, and I certainly, I'm sure Carl will have more to say on this, but I certainly think it fits very naturally within the active inference formulations.
Yeah, that was also my sort of initial thought. I mean, at the very, very, very basic level, and again, please correct me if I'm wrong, but when you're talking about super classic stuff, like, as I said, even attachment and Peter Fonagy's epistemic trust ideas, or very basic things like the cognitive dissonance by Festinger. I mean, he opens the book with this idea that you've been told, for example, don't smoke. Smoking is bad, but you smoke. So then his main paradigm there is that, well, you only have two levers. One is you change your behavior. You stop smoking, which is you're changing the environment, right? You don't pick up the smoke. Or you change your model, your working model, which is by saying, well, my granddad smoked and lived to 110, or maybe I smoke less now than I used to, or cigarettes have great filters now, or whatever. And I think those two speak again, and you can draw parallels with mental health, of course, and especially you see that in children, where you have either internalizing problems or externalizing. They will either lash out generally, and of course, then as they grow, the two converge and they affect each other, one another, or they will just close in, low self-disclosure, low openness, low. And as I said, all the way back to attachment with the strange situation task, where a child will either go out and search the room away from the mother, or will, observe and sort of, which is also inference, of course, observing, but I mean, restrict the range of observation. So to me, that seems to go all the way back, and that's why I'm wondering if the motor function, the motor part of the brain, to put it simply, has something that speaks to that, a separation of network areas that speaks to that.
And I think because I don't do motor control stuff, so I don't feel confident that I can speak to that concretely on like neurobiological level, but certainly there may be, or certainly there should be things in common at the very motor control level, and at the more, let's say, slower time scale of should I go search the room and so on.
Right. And one more thing here, sorry to interrupt, Peter, but just one more thing here, in that a separate empirical work that we've done recently is, unfortunately, that's still again under review, but it's quite solid, but building what we did on theory of mind. What we have shown is that actually spatial ability, verbal ability, we know that it's related to theory of mind and so on, but spatial ability is related to both emotion regulation, so children with good navigation skills and spatial construction skills are more self-regulated and have greater theory of mind. And again, when looking at the neural correlates, these things seem to be related. And I'm hoping to in a UCL collaboration to look at that from the actual neuroscientific perspective. Sorry, I forget the group now, but we're starting to see if that can actually be measured. So using video games, so people who actually look at, I mean, that's one potential way to look at it. There are others, but if the ability to navigate spatial and have spatial skills is also related to theory of mind, and some papers have actually alluded to that as well. And so the ultimate sort of mapping there would be that the ability to understand physical space, the ability to understand where distinct objects from me as a 3-year-old, 2-year-old, and earlier, distinct objects lie and their relationship to me and each other, that ability may then generalize to the ability of understanding other minds. So the position of people in social space, rather.
Mm.
And the remarkable thing is that this is related to the, I have the book here somewhere, sorry, Lewin's, the Gestalt guy, the topological psychology stuff. So when he describes, it's called topological psychology, and he describes the mother and child dyad in terms of those. So the thoughts of one another and the topology of space. If there's an obstacle and the mother removes and so on, it's quite fascinating. But I mean, that was 1930s. So anyway.
Exciting. I'll let Patrice enter the stage, so I don't spend all the time talking myself.
Hi. First of all, Dimitris, good presentation. I especially like how you're starting out saying, you know, I began wondering and wondering and wondering, and then thought I'd come and talk to people, which I think is always a good way to go. And I'm a psychotherapist and a psychiatrist, and I've been wondering this for the last 15 years myself. I think you have a very good point. You're quantifying it, which I qualify it. But the idea just now when you said, I mean, there's several, to me, obvious connections, having both lived with people in individual and group psychotherapy for long periods of time. But the idea of stability in space, and then it goes to epistemic trust, and you can even talk fear of abandonment or fear of engulfment. So if the mother stays relatively stable in terms of just time, like she doesn't move too fast, she doesn't move too erratically, she is consistent, that will lead to continued expectation of that, but that develops then prediction and prediction and prediction. And then with prediction comes an expectation of, if I do this, then that. And when you look at the fine motor, gross motor, the child who can, if I do this, then that, will develop all those things because their behavior brings about a result. So I think when you started thinking about this, I'm like, yeah, I agree. I think more interpersonally, like more probably theory of mind and communication, but I know that I react to my patients based on their fine motor and gross motor process, like that has, and inevitably see the patients who have these elements of neuroticism have a persistent confusion in their fine motor movements that promotes the neuroticism. They will not, and I'll bring in eye contact with this in terms of if they're looking at me, and one patient I'm thinking in particular has it's gross motor too, but persists in something I think she did when she was a child, which is her hands define everything. And when she's uncomfortable, she persistently uses her hands to define it. And I think there wasn't enough communication, there wasn't enough action of those hands towards getting something. So they became a communication means. And the communication always signals to her, like, no, it's still bad. And so, you know, I could go down the list. I'm not familiar with the cybernetic theory per se, although I think the basic idea of what you're saying regarding these things lead to that, it is prediction. And then it's it's a willingness to explore if the prediction has been more stable, along with all the other elements that you mentioned. But I applaud you for moving ahead even when you weren't sure, and seeing where it fits in. So
thank you.
That's expressed in attachment. I mean, attachment theory has consistency in it, and the expectations of each and the communication of each. And some of those things happen in a fine motor and gross motor way. There are children who transcend that because the mother helps them transcend that. Even if you look at scaffolding, which is where the child can't do something and the parent can hold them here and they can do something. If the parent's willing to hold them here, they're willing to say, here, we're going to go explore. We're you know, if they let them reach, we're going to go explore. So in attachment, you have those elements too, which I think you can break down as you're doing into like active inference components, and how does the I mean, how does the mother support it, and how does the body physically of the child, and then how does that interaction support it?
Yeah, and I think the cybernetic, by the way, which is baked in active inference, but in cybernetic Big Five theory is a kind of a new thing, very new for the personality psychologists. I think the cybernetic aspect is simply to not simply, it's quite deep, but it seems to me that in the personality psychology literature and domain, it's simply trying to take people away from the notion of you know, of aspects of the soul that are kind of somehow given, and takes it into the realm of the biological, that there are biological reasons of why one is more open to experience. Sorry, when I say biological, I don't mean purely mechanistic. I mean biological plus attachment in the that sense. Plus early experiences, formative, very formative experiences that have all sorts of influence biologically, epigenetically, and so on. So I think that's what it's trying to do with that cybernetic, that at the end of the day, we do have goals and we are self-adaptive organisms that self-correct. Now, to me, the big gap there seems to be, how does it include other people? So, for example, in the theory of mind aspect, I know there are papers, active inference and theory of mind, but it's still a question. How exactly it goes on there? What is it? Is it a shifting Markov blanket, let's say, that encompasses then two people that have shared intentionality? I'm not sure how it works, but I think it's certainly there, baked in somehow.
Yeah, you're in the area, and cybernetics means development, and it means both the emotional attachment development and the physical development. The word cybernetic, I'm old enough to remember when it originally came out in the 60s, and it was just a confused kind of thing, but I understand what you're saying there. And so I hope you keep on looking, and anytime you want to talk, I'll send you an email.
Right. Yeah, thank you.
Thank you, Patrice. I have a small further comment, and then we can see if there are more people with questions or comments. And otherwise, I'm sure Carl is what's the word? Looking forward to summarizing or and giving feedback. No, I just wanted to stay a little bit with this, the stability and plasticity distinction, and what that might look like in an active inference context. And then Carl can correct me for whenever I say something wrong. But of course, it's reminiscent to a kind of a learning rate. So how much do my beliefs update when I get input? And I think an important thing is to distinguish two things from each other that are maybe similar and certainly related, but not the same. One thing being, given that I get some inputs, how much do I change my beliefs?
Right.
And concurrently my behavior, my new behavior. This would be what's called learning rate in reinforcement learning context, and active inference has an equivalent to this.
Okay, can I just clarify and make sure I understand this? So
yes.
So learning rate of 0 would mean that your input, your sensoria, are screaming with lots of new information, but none of it ends up updating your generative model, your priors.
Yes, and
Okay.
there's not an active inference a learning rate parameter.
Okay.
Instead, it depends on my certainty.
Okay. So is
but
it precision over?
Yeah. Yes. So
Okay.
so the combination of how certain I am in my current beliefs
Mhm.
and how much precision I ascribe to the inputs I get.
Okay. Okay.
So in this case, we could have a situation where someone tells me something about the world, and because I either am very certain in my beliefs that I currently have, or because I don't think their input is very precise, so I think they're noisy, they might be wrong, I don't change my beliefs.
Right. Okay.
This would be what corresponds to having a low learning rate. And of course, the point in active inference is to try and figure out how certain should I be in my beliefs, and how much precision should I ascribe to the inputs I get. That's what the active inference models try to do.
Yeah.
But this is one case, and this is in the case where I get an input and then I change my beliefs. Another situation is when I choose whether to go and sample new data, whether to explore. And they're not the same in the sense that in the former, I'm not making actions to produce data that I can use. I'm not, so to speak, walking around the room and learning more. While the second one, what we might call foraging or exploratory behavior, is maybe slightly different from how much I learn from my environment. But I think that both of these, let's say exploratory behavior and how much I update, would be a kind of plasticity. It strikes me as in this framework. And in active inference, the exploratory behavior emerges if I think there's high epistemic gain. So in other words, if I think I can learn a lot from the environment and specific parts of the environment, then I will go and sample from that. Yes, and yes, and importantly, these two phenomena, so both the updating my beliefs and also the going and looking for behavior, are not, let's say, at least in the models that I'm used to working with, inherently decided in the model. They're a consequence of my certainty about the world and about the inputs I get from the world and so on. And those certainties are in turn a consequence of my generative model of the world, and of the observations I get.
Okay. And again, just to be sure I'm not on the wrong path here, when we say generative model,
yes,
and we go back to, for example, an infant, am I right in saying that, for example, the dyadic interactions with the mum or dad, primary caregiver, and the attachment is a major factor of the generative model? So so for translating FEP AI into, for example, infants, when we talk about an infant's generative model, that would include the entire evolutionary culture and biology of our species, right? That encodes in genes and everything, and the early experiences of attachment, even down to prenatal and birth, right? Am I right in saying that the generative model bakes in all of that?
Yes, I think I would usually say something like the generative model encodes the infant's beliefs about how the world works.
Right.
And this model is updated, so it's changed over time depending on its inputs, and of course then primarily, or to a large degree, on its interactions with its mother. So it's shaped. The model is shaped.
Correct.
And and you could of course imagine that children who grow up with parents who behave in one way end up with a model or with beliefs that the world is in general very volatile, for example.
Yeah.
So, and that, in case, then changes their certainty and their exploratory behavior later.
So in that sense, and this is beyond the main conversation, just to make sure the sort of markings around the territory, let's say, are right, or delineation. In that sense, then, the generative model in the FEP AI sense is an inherently, as we said, cybernetic and much broader way of that maps onto what Piaget called schemas and to what, for example, Bowlby called internal working models. Am I right in that
I'm
broadly?
not familiar with internal working models. Schemas, that would be the expectations we have to the environment. Yeah, maybe Patrice will know better.
Yeah.
She raises her hand.
Yeah.
Comes to the rescue.
Yes, it can. There are, actually, when you were saying this, if you think of the generative model of the infant,
yep,
we understand it doesn't include thought.
Sorry,
it doesn't include thought. It's a
right.
process, entirely process. So then it can go to the schema, and it can go to really. They may not accept the generative model statement, but the generative model statement accepts theirs.
Right.
in its moment-to-moment form.
Got it.
Because it is what then develops as expectation and so on and so forth.
Right.
Which is what's in schema. And
yeah. Okay, got it. I see. And that an internal working model in the Bowlby sense is the precursor. Yeah. Okay.
Very much so. Very much so. Which is yes, what one of the things that originally caught my attention, because his internal working model includes all the things of motor function, communication,
right,
attention, and touch, and everything that then produces a generative model. This is the way the world is.
Right. Yes, and I liked Peter's example. Peter, you said for safety, for example, you said safe, and that's something I'm working on with Slavich, George Slavich in UCLA, stress sort of person, and his social safety theory is essentially that really predominant schema of whether you feel generally threatened or safe. And then, of course, that goes all the way back down, all through the main childhood schemas and back down to attachment. And the point is that it's not in the head, right? I mean, it translates into every bodily function we can think of, endocrinologically, neuronally, and everything. So again, if it's something percolates across the entire organism, it means that it's probably going back to something fundamental as movement or something like motor function, basic communicative function. Or it could be related. That's
yes, you're right. And then you can add in all the other layers of touch and sound and even interoception, which is that's all formed through generative model. I mean, becomes generative models through the moment-to-moment contact.
Right.
Which is attachment.
Right.
In generative modeling terms, you can talk about having hierarchical models. So you have a lower time scale, so assumptions about the world on lower time scales that affect the shorter ones. And that then, depending on the model structures, of course, but that then can probably propagate out through the rest of the system. So that's maybe one hypothesis, that this plasticity stability distinction depends on some very deep in the hierarchy of the generative model assumptions about how unpredictable the world is, for example. Yes, although I don't dare to make a strong hypothesis at this point. But,
just one final thought, because it's just so interesting. The way you talk about it, Peter, just generates further thoughts and everything else we've said. But in the hierarchical sense of an organism, especially, let's say, humans, is it possible perhaps that different, so the main, and this speaks again to the physics aspects of interdependent systems, complex systems. So if we take the human as an organism, for example, I mean, the equivalent in solid state would be a highly complex spin system configuration, so many subparts. And then, of course, the cell or the liver or the heart are subsystems. Now, would it be fair to say that they have to be stable? So they're very goal-oriented, the liver. The liver has to, or the lung has to be very, very stable, meaning goal-oriented, not distracted. of course, a virus is a distraction, but you have to keep distracted. And as you go higher up in the levels of, I guess, our being, all the way to cognition, then at the cognitive level, the planning level, curiosity, planning, and so on, is where plasticity comes into full play. But then again, the anti-fragile biological elements we have, that we react to a virus, that's also plasticity in a way. Anyway, sorry, it's getting
that's a very interesting question, whether the plasticity stability balance is different depending on which physical
level,
spatial temporal level you are.
Yeah,
maybe Carlos has thoughts on this. It sounds likely, but I can't say for sure. But before Carl, I think we have time for one more question, and I see that Mo has their hand up.
Yeah, thank you. Are you able to hear me?
Yep.
Yes. Okay, great. So I will couch my question in with a disclaimer that I am in no way an expert in any of these fields. I'm here truly as a fly on the wall. I want to learn and not contribute too much. But for the past few years, I had been working in psychometrics, specifically in IO psychology. And one of the things that I came across quite a bit was this understanding, or maybe a renewed interest in whether or not intrinsic motivators affect the big five personality traits or vice versa. And typically in the literature, from what I've seen, there's a general assumption, one of the kind of the early tenets is the assumption that they will not take consideration of each other in the research. And you will see some literature in which there's an attempt at seeing if there's any cross-loading or correlation covariance, and typically very limited amounts are found, so it's not such a big deal. In this instance, it piques my interest because one of the most common and typically considered universal interests is what sometimes gets called hands-on motivation. I think it's called realistic interest. And that seems to me to be potentially a conduit through which you could either say a person is in their development interested and motivated by tactile responses or whatever other quote unquote hands-on feedback, and that could be motivating the result of them loading more directly on one personality trait or another. And so, I don't know that you're going to be able to necessarily answer a question directly. And I'm sorry, I'm in morning duties right now because I'm in the States. And so there were pieces of the talk that I missed. But ultimately, if you're able to at least lend comment to that or refer to the fact that that's a point potentially of further research, we may find that there's something else that's involved there, which is essentially, from a young age, are we motivated to develop the personalities in such a way that effectively speak to the things that interest us the most? So I'd love to know if you had any thoughts on that.
Yeah. Well, thank you very much for the question. I will have to think about it a lot more, but my gut reaction is that I missed something purposefully. I left it out of the talk because of also lack of time and so on, to be as sharp as possible. But the thing I missed out the most is the sort of endocrinological hormonal aspect, which is that in cybernetic Big Five, actually in the Saffron and the Young paper itself, they're making a connection between FEPAI and the cybernetic aspect and dopamine and sorry, I forget the other part, but the point being that so I don't know about realistic interest. I will have to look into that. But the point is that motivation and the Big Five are interrelated. Of course, they co-develop. So through development, there is a bidirectional influence that is mediated or rather encoded by the dopaminergic system and at least one more, so at least two. Now, from my perspective, I also know through my work in theory of mind and trust, which is where I'm going to now, that the oxytocin and and another one, vasopressin, but especially oxytocin system is also very much involved. And we mentioned earlier, Patrice mentioned around touch and so on. So touch, trust, all of those are related to the oxytocin system, and attachment, of course, and birth. So so motivation and Big Five, are they related? Yes, for sure. And are they related probably at a deep biological level? I think that's fair to say. And then the connection between the personality, embodied personality, and FEPAI and stability plasticity may well come through those, not just the neural correlates, but the neuroendocrine systems involved. So that's probably not an answer to what you asked more, but yeah, look into realistic interest as well and think about it some more. But those were my initial thoughts.
Well, thank you very much. Actually, I think that addresses it at a more fundamental level, potentially, where what you're considering here are the physiological mechanisms of determining whether or not someone finds themselves motivated, regardless of what that motivator is. So yeah. I suppose that is actually even more powerful in many ways.
Thank you, Mo. Are there any last questions or comments? Then I do think it is your turn, Carl.
Is it my turn now?
Yes, indeed.
Very good. Right, so there's an impossible task ahead in terms of trying to summarize all of that, which would take another day, I think. Excellent presentation, lots of wonderful ideas, and a great discussion, which I can't possibly summarize because I can't keep everything in my head. What I've done while you've been talking is identify some key papers that I think speak at a broad scale to the basic arguments that you were presenting and also unpacking in the discussion. I have to say, you seem to be extremely fluent and know most of the literature, at least at a narrative level. So I suspect you've probably seen many of the papers I'm going to briefly go through, having shared my screen previously. But if you haven't, I think they would be useful background reading. Then some of them will be specifically addressing Peter's original question, how can we help? And specifically in response to your questions, what would be the utility of being able to simulate this kind of thing? But most of them are just, if you like, endorsements from other points of view, and also picking up on little things you let slip, like quantum information theory and oxytocin. So it's a bit of a potpourri, I'm afraid, and there's a lot of them. So I'm just going to race through them. Yeah. But just to frame, and in so doing, hopefully I'll remember why I selected them, because most of them were selected to make a particular point at some point during the presentation or the discussions. But before I do that, just to sort of frame this and revisit that conversation again with Peter and possibly Patrice. Well, the sort of technical frame that you are going to, you may well find useful in terms of motivating why do you go to the technical literature on the free energy principle or active inference to understand what has been understood quite deeply for decades, if not millennia. And I think one way of addressing that is just to make 2 points. First of all, that formal account on offer with the free energy principle and the application of the free energy principle to behavior, namely active inference, sort of allows you to carve up different kinds of plasticity versus stability. And in so doing, provides you a sort of taxonomy at the level of which the phenotyping in terms of personalities, or in terms of neuromodulators, or in terms of attachment theory, however you want to sort of phenotype somebody, gives you an ontology or a taxonomy of the kind of level of description. And what I wanted to emphasize was that, you know, stability and plasticity are just two sides possibly of the same coin that describe any self-organizing system. So I could use your rhetoric and all the concepts, including the cybernetic big five, and I could apply that to a single cell. For example, Mike Levin's Xenobot. You know, this is a curious one. This one's fixed in its ways. This one seems quite open. So this is the notion of basal cognition, that all of the ways that we can describe self-organization can be applied at any level to a certain extent with a little bit of poetic license. So that begs the question, well, it motivates an application of the free energy principle to self-organization in the sense that if you can understand the fundamentals of self-organizing systems, from your point of view, people, then you will have a formal understanding of the mechanisms that underwrite that kind of self-organization. And I keep wishing on about that because self-organization has effectively three kinds, which means that there are going to be three kinds of stability and plasticity. And these are very simple. They're just organized into different times or temporal scales. So first of all, there is, if you now describe self-organization as belief updating, so you know you're putting a teleology on self-organization and describing it, it looks as if this particle or this person or this baby is behaving in a way that I can describe in terms of updating her world model. And just incidentally, I think that world model, generative model, internal world model, generative world model, scheme, they're all names for the same thing. You know, and you could quite, I think, plausibly use the notion of internal world model, you know, in psychology to mean exactly the same as it means in machine learning nowadays in the context of generative AI. As Patrice said, it's just your model of how things work. And in that sense, you can look at anything and say it is behaving in a way such that it looks as if it is updating its model. But that updating, technically a Bayesian belief updating, that's the Bayesian mechanics that comes out of the energy principle, proceeds in nested timescales. So the first level of belief updating would be inference. This would be active, vanilla active inference, making choices under uncertainty in the moment that could evince a degree of curiosity or sensation or information seeking, or it could look like the kind of behavior that is dictated by goal seeking or reward pointing behavior, depending upon the precision of your various beliefs. But crucially, there's no learning here. It's just making sense of the world in the moment and updating my beliefs about latent states of the world and what I am going to do in this context. So that's sort of active inference proper. But then you discuss this later on in the discussion. There's another timescale, which is learning. So that takes longer. So you can do lots and lots of active inference, and then slowly start to learn the contingencies, the parameters of your generative model, as it were. And this can be at a neurodevelopmental scale. And you talked about sort of dyadic interactions with the primary care and attachment theory, you know, right through to the, development in adolescence. So it could be neurodevelopmental, but also it could be riding a bike, or it could be learning how to play a new sport, or and all other kinds of more pro-social learning. But there is a final level, which I think it's useful just to bear in mind, which is not the parameters updating, Bayesian belief updating about the parameters of your world model, but the very model in and of itself. And that's sometimes referred to as structure learning, certainly in sort of radical inactivism. In machine learning and statistics, it's effectively Bayesian model selection. So you might think in a developmental context, it's not just a question of using associative plasticity or experience-dependent plasticity to consolidate the right connections, the right parameters, the right contingencies, the right laws in your generative model that is necessary to do good inference. But the very structure, the number of nodes, the number of hierarchical levels, the functional anatomy and architecture in and of itself has to be optimized and has to be updated in light of experience and priors that could be epigenetic or implicit in, say, cultural niche construction and the way that you are brought up. So I think it might be useful to say that stability and plasticity can be in the moment, as evinced by your behavior. It can be over a period of learning, which is this fine-tuning or optimizing the parameters of your world model or your generative model, or it could be structure learning at a developmental level, or you could even argue at an evolutionary level. And I just thought it was useful because, of course, your empirical paradigm does actually span multiple timescales. You're doing your little tests in the moment, in the minute, with tests about active inference, but you're looking at, basically what that portends for subsequent structure and what we call parametric learning. You can also cast the structure learning as selecting the right model structure in order to then optimize the parameters under that model. So you can think of this as some active inference, active learning, and active selection. So using active selection to denote a kind of Bayesian model selection that depends upon accepting it if it ticks the boxes in terms of maximizing model evidence, or as Jakob Howell would say, self-evidencing. So I thought that might be quite useful because you talked about plasticity and stability. I thought at slightly different time scales at different points in the conversation. And normally that wouldn't matter. You can just assume that if somebody is very explorative in the moment, it's likely also that is subtended by a capacity to learn. They're impressionable, as say a young child might be, which itself goes hand in hand with the ability to explore new model spaces and to select different kinds of structures and the like. But it doesn't have to be like that. And certainly when it comes to simulating these things, you really have to be very specific about the kind of generalized homeostasis that entailed by plasticity and stability that you want to simulate, and or deliberately address through simulation the link between the two scales. So is it the case that somebody who is more impressionable and is more able to update the parameters and learn more, are they also the kind of people that would respond to a foraging task in the moment with more curious active inference, and vice versa? So you could in principle answer these questions. It's an interesting question from the point of view of theoretical biology more generally, in the sense you get a similar distinction between very slow adaptivity in the context of, say, second order selection or selection for selectability. So here instead of learning, we've now got sort of mutation rates. The slowest time scale is the selection for selectability. So you're not saying what you will select for or what you will learn, but the rate at which you can do so. And that can often lead to consequences at a finer time scale in terms of what is actually selected in a volatile environment. So the second sort of overarching point I wanted to make was just something you've already discussed, which is this fundamental link and equivalence between uncertainty, inverse uncertainty, namely precision, and learning rate. So all of these are just the same thing. So if you just think about it very, very generally, I mean, you said this effectively, so just to make sure I've got this clear, and you did get it clear, but it's such an important point. I just wanted to re-emphasize it, that you've got some change in your beliefs, and it could be about the structure, it could be about the parameters, or it could be about latent states of the kind model, say structural equation modeling, and you've got some evidence at hand, and the rate at which the rate of change of your belief structure and the evidence at hand has a constant of proportionality. That is the learning rate. It is the precision. It's exactly as Peter said. It's just how much weight do you afford this evidence in terms of, and exactly as you say, if the precision is 0, there will be no impact of this outcome or sensory evidence or experience on any kind of updating, simply because you turn the learning rate down to zero, or that rate constant down to zero. And because precision is inverse uncertainty, that what that basically says is you're affording this kind of information infinite uncertainty. It's basically infinite signal to noise. Signal to noise, the precision, or infinitely high noise. There's nothing useful here. So I think it's useful for readers, I think, just to read that. The things like alpha in the Riscora-Wagner model, they're just precisions. Softmax parameters in choice rules, inverse temperature parameters, they're just precisions. Precision is really important, this sort of quality of the belief. It doesn't tell you what you believe, or what your mean is, or your location parameter, or your most likely thing is, but it tells you how confident or how certain you are about it, and that really determines the nature of belief updating at different scales. I say that because you're asking, what's the validity of Adam Safron and de Young's sort of proposal for that particular world model or generative model to be a scaffold for different kinds of personality. I think that was very plausible. I mean, on the one hand, a couple of things to say here. It foregrounds, I think, a couple of technical and important points. That Markov decision process that they showed is not an arbitrary and ad hoc choice. That particular kind of model is extremely generic and universal. In fact, it would be difficult to think of any process in the universe, certainly in terms of things that we can model and understand, that could not be written in terms of that structure. So it's if you understand belief updating under these generic Markovian processes, then you've probably got a good understanding in any context under any kind of generative model. So I think that's an important thing. The other important thing to bear in mind is that if the differences, if inter-individual differences of the sort scored by personality rest upon the generative model, and particularly in the priors entailed by that generative model you bring to the table at the point of having a personality or being assessed for it, then it is likely that most of the interesting differences between people lie in the precisions. And that is certainly true in psychopathology. So computational psychiatry almost universally focuses on the precisions as the key priors that discriminate one person from another person, or one cohort from another cohort. It doesn't have to be like that. Of course, people can learn different things and have different expectations and beliefs. But it seems that, if you like, the type of thing you are, the kind of thing you are, seems to rest very much on the precisions. And I emphasize that because precision is just a description of a belief or conditional probability distribution. It's like variance. So you can't just say, oh, my precision's broken, doctor. You have to say, what precision of what? So any belief structure, and which means any latent state in that graphical model, that MDP model that you showed earlier on, is equipped with the precision. And as such, there are lots of opportunities to ask, well, what would happen if I varied the precision here as opposed to the precision here? And I suspect that is the genesis of this 5-dimensional personality structure. There are just 5 cardinal precisions in a coarse-grained world model of this sort. And the particular hypothesis or proposal in Adam Safron and the de Lange paper, I think probably very sensibly just identified 5 key precisions, which make a lot of sense in terms of that sort of cybernetic big 5. And certainly, I agree with all the other members of the audience that just eyeballing them, you can see immediately, the prime candidates. Changing the position here is going to cause variation along this particular aspect, sort of either information seeking or reward seeking or explorative or open, whatever. So I think that presents an interesting opportunity. Now, given all the collaborations and the amount of work and the different perspectives you've already articulated in conversation, I suspect you probably don't have time to do these simulations yourself. But if you could get a PhD student or somebody to simulate this, this would be a golden opportunity now, just to take a paradigm that you would possibly even use for personality phenotyping at any stage in neurodevelopment, simulate that under under one of these Markov decision process models, using the worked examples in the literature and off-the-shelf code, either in MATLAB from the SPM website and GitHub, or in Python using PyMDP. All of these things I'll just briefly flash up so that you've got a visual record on the recording of where to access these things. So don't worry about taking notes or anything. What you can then do is generate responses to your favorite paradigm, impulsivity paradigm, or we'll see an example of that, a sort of social withdrawal paradigm or something. So these are out there, they are published. Well, as you say, what hasn't been done is to now reproduce these simulated behaviors, and they can be either literally behaviors of kind you would measure in choice behavior, but you can also simulate reaction times. You can also simulate electrophysiological responses of the kind you measure with EEG. And with these particular Markov decision processes, of the one you showed in the Saffron and DeYoung paper, you can also simulate dopaminergic discharges, because they have a very particular role in nuancing the precision of this and that. So if you can simulate any of these measurable kinds of responses, you can now, by changing the precisions here and there, you can now simulate the variability in the responses of, say, 5 of your favorite precision parameters in these models. You now know you've generated a data set that has a 5-dimensional structure to it that you can then do a PCA on, or indeed apply the big 5 inventories or tools coarse-grained sufficiently to match your paradigm, to actually see whether you can reproduce that 5-dimensional personality structure, simply because you know formally the structure of the underlying world model or generative model, and you know where to introduce the right kind of variability through the precisions of 5 or more of the belief structures entailed by that. So that would be one, I think, very powerful way of using or applying active inference formally in a non-narrative context to establish a proof of principle that you can generate a 5-dimensional personality space just by small random perturbations on the precision of a very generic universal world model of a particular paradigm that speaks to the kind of choice behaviors that discriminate one kind of personality from another kind of personality. If you can do that, then, as Peter was intimating, you now have the opportunity, having validated your particular model, to reproduce that paradigm in real people. And then the trick is, this is the computational phenotyping. Then what you do is you adjust the precisions until the probability of the empirical, the subject-specific behavior is maximized. So you literally fit the model so that it becomes a digital twin of this person's personality as measured by this particular paradigm. And you do that very simple. Well, it's not simple. It actually takes hours and hours of compute time and a lot of experience. But theoretically, it's very simple. All you're doing is doing a gradient descent on the precisions of your model until the probability distribution over the actions that are, or the choices that are selected, renders the empirical responses the most likely. And then you've now got basically a phenotype, a digital twin of this person. And then you repeat for another person, another person, another person. And again, if you've got them independently rated on on some personality scale, you can now look at the formal mapping between the precisions and the, if you like, a kind of personality rating that is face validated by being applied to a real person, as it were.
Yeah.
So there are all sorts of really interesting games you can play to actually get at the mechanics of personality by generating the behaviors that enable people to infer what kind of personality is required. So just to rehearse, those are my that was my feedback in terms of just purely theoretical and formal notions that, first of all, stability and plasticity are the fundamentally or our fundamental understanding the very essence and nature of self-organization. Self-organization has separable timescales. That means that the same game can be played at different timescales, and thereby nesting one level under another level. All of this speaks to dynamics and belief updating, and belief updating is proportional to precision, and precision can be an attribute of any belief structure at any given timescale. You can tie down that generic story to the big five and a generic Markov decision process by simulating behavior, choice behavior, by manipulating the precisions of a generative model, and demonstrate a forward mapping from your internal world model equipped with the right kinds of precisions and the behaviors that would be associated with a certain personality. And then finally, computationally, you can use this model to then link to the empirical literature by phenotyping any given person under this model. It would be an ambitious program. I repeat, you've got too much to do, but if you can find somebody to do that, I think that would be a really useful way of proceeding. I'm talking fast because I realise it's getting very late, and I've got lots of papers I want to show you, and I know this has been recorded, so you can play that back at 1.5 or 1.75, and not to waste time and pick out the bits that you thought were interesting. I'm going to now share my screen and make sure I've said all the important things. Now, how do we do that? Oh no. Oh, I froze there. Am I? Oh,
Yeah,
I'm still here. Am I?
Yeah.
Excellent. Okay. So again, I tried to order them, but I got confused because you kept changing topic. So I'm not sure I got the right order. But this paper is, I think, if you haven't read it, you'll enjoy reading it, because a lot of your discussion was, clearly in the context of dyadic and multi-agent interactions and belief sharing, even through to sort of cultural niche construction in terms of shaping our world models and implicit personalities. But the reason I've actually put it up is just to reiterate this basic ontology of self-organization or self-evidencing at different timescales, considered in terms of inference, learning, and selection as maximizing the evidence about the states, parameters, and structure of world models. So it just takes you through the calculus of that, and I thought that would be a useful way to scaffold your discussion of stability and plasticity. So federated inference and belief sharing came out, this year. Good. So that's that one. You mentioned spin glasses. I just put this up for fun. So
Great.
Connor Hines, who was mentioned during the discussion as the author of PyMDP, the Python version of active inference as implemented with Markov decision processes. So he wrote this with colleagues at Sussex and around, and his friend Brennan, looking at the exchange of beliefs in an ensemble model as a spin glass system, and just looking at the different kinds of dynamics that ensued. This has now been published. This is the archived version. But I thought if you really liked spin glass systems, you should look at the work of recent work of Connor Hines, applying that as a model of collective active inference in an ensemble setting. You also talked a lot about sort of attachment and whether one could use the notion of, or what the notion of a generative model would mean in the context of early neurodevelopment, and later on, you then went on to implicate dopamine and neuromodulatory neurotransmitter systems in playing a role in the form of that, in the way that these models were selected and then learned during early prosocial and affiliative-like interactions with the primary carer. There's a lot of literature on this, and I'm not sure if Patrice is still here, but she could certainly send you a lot of papers on this. But I put this one up, written with Dr. Quattrocchi, who was in Boston, simply because, first of all, it does focus on the importance of oxytocin in this model building in early neurodevelopment, but more importantly, simply because it takes you through how you can tell a story about a baby building their own world model. And of course, the most important aspect of that model is building a model of mum, and then realizing that possibly you are something like mum. So I just put this up because it might be quite didactic in terms of demystifying the concept of a generative model and the importance of dyadic interactions at a neonatal stage in building some of the fundaments of that model, so, that would entail a minimal selfhood and the right kind of interoception that implicitly rests upon having a self model which enables you to attribute the causes of your sensations to either self or mother or other. So if you haven't read that this may be, I thought, it's a bit old now, but it's still a useful, I think, sort of summary of the different ways in which one can use the concept of a world model. Oh yeah, you said you liked quantum information theory. I didn't see much quantum information theory or quantum computing in your talk, but if you like that, you might want to look at the work of Chris Fields. This is one of a series of papers he's written recently, applying, or not applying the free energy principle. Well, yes, now applying the free energy principle in the context of quantum information theory, specifically asking about whether the free energy principle is just the principle of unitarity, but with a specific focus on the holographic screen as the equivalent of a Markov blanket, or that boundary between self and mother or other in the classical setup. So that's just for fun. I don't think that's going to actually help you any. Yeah, this paper is just a foundational paper. Again, you probably know this, although you seemed a bit shy or humble in terms of the mechanics of it, but just to emphasize the importance of applying, focusing on where the precisions might be, very much in the spirit of the Saffron and DeYoung paper. We're talking about sort of the personality of things that have agency. And so what are the belief structures that underwrite agency? Well, basically, those are the ones that the beliefs that underwrite planning as inference in the moment. And that in my world, or our world, is expected free energy. And that's nice because you can carve up expected free energy in a number of ways, all of which speak to this one plasticity stability axis, and I think at a finer grain also speak to different aspects of the sort of you shouldn't call aspects, but the five trays but the meta tray just hits you in the face when you start to rearrange the expected free energy, which can be derived from first principles for any self-organizing system. You can read in terms of risk or expected cost, and ambiguity, or intrinsic and extrinsic value, or intrinsic motivation, extrinsic motivation, just highlighting the yin-yang between information seeking or ambiguity minimizing behavior relative to goal-seeking or equivalently risk minimizing behavior. And when one looks at these kinds of equations, the first thing you ask yourself is, okay, so if I want to know what's going to contribute to my behavior, I need to know the precision of these various beliefs. So the precision of these beliefs about the causes of my sensations or the latent states of the world or my preferred outcomes can be very context sensitive, but also rest very much upon my prior preferences that can have an arbitrary precision. And just to cut a long story short, if these prior preferences, those that determine the kind of states that I anticipate will ensue following action, effectively the outcomes that characterize something like me, or what I believe me to be. If these are very precise, these are going to overwhelm the plasticity in terms of behavior, the exploratory aspects of behavior. Whereas if these are very imprecise, then I'm just left with these epistemic imperatives, and they look as if I'm much more curious and much more explorative. What this doesn't show is, of course, you will now have a prior about the habit. So now you've also got how precise is your habit, which means that I can either be habitual or I can be informed and deliberative. And if I'm deliberative, I can now either be very inquisitive or I can be very goal-driven. And so just looking at the functional form of the imperatives for choice behavior in this instance tells you immediately you're going to have an interesting game linking the precision of various beliefs over habits and expected free energy and all its constituents that could give you a very rich structure for generating different kinds of choices given exactly the same sense of information, because all of this depends upon your prior beliefs, the structure of your generating model, generating beliefs about states of the world, but also your prior preferences. So this is a kind of, if you like, getting into the weeds of the mechanics that starts to leverage the formal aspects of the free energy principle in relation to how it would manifest in more narrative accounts or in terms of empirical phenotyping with the personality instruments. I put these things up just if you haven't come across them, you might like to at the weekend, not this weekend, but a weekend, just to see how other people outside the personality field write about or apply the free energy principle or active inference. Again, if you've seen this, please forgive me. If not, then you might enjoy reading this. This is a recent paper I think came out just a few weeks or months ago, talking about self-esteem that may underwrite typical behavior. Oh, no, I didn't want to do that one. Oh well, never mind. Right, so I'm now moving on to specific paradigms that have been implemented using that Markov decision process that you might, if you had this hypothetical PhD student or team doing the simulations, want to look at. This one I thought might be particularly apt in terms of impulsivity and uses, unlike the tutorial which you correctly identified, just provided a worked example from the literature without showing you how it actually worked or spoke to specifically different personality or types. This, I think is an example that is probably getting quite close to what you might find is useful. So this was effectively a paradigm looking at impulsivity in a choice, using exactly the same kind of model that you actually showed on the screen. I won't take you through the details of it, but other than to recommend you read this and similar papers and then pick your favorite game or set of games that has already been modeled and validated, so you don't have to argue against reviewers that it needs any further validation. This was another example I thought you should look at, or well, when you get your hypothetical PhD student. This was written by my friends, Axel and Paul Babcock in Australia. And the reason it came to mind was because of your conversations about sort of pro-social behavior, approach versus avoid in a social context. So what they were doing here is again explicitly modeling choice behavior in terms of shall I go out or not, given how I feel about the consequences of going out or not, or making particular inquiries. Sounds quite abstract, but it's actually relatively simple to model these kinds of paradigms. And then what you can do is go in and change the precision of various beliefs, either by hand or explicitly parameterizing various structures in this model, equipping them with a precision parameter. So that was one, basically trying to simulate a depressive approach to social interactions. This is an interesting example, and I put it up deliberately because at one point you were talking about curiosity and the ability to entertain other ways of looking at things, and being, creative. Implicitly, you were saying, being creative in terms of exploring nuances to your world model. Technically, that would be the model selection or active selection, which is the same as structure learning. And this paper was again a worked paradigm. Actually has simulations of curiosity that rest explicitly on the ability to entertain new models by comparing different hypotheses, structures that explain all the evidence, all the sensory evidence that you've accumulated during a game, or say during the day, and showing how that contextualizes and makes the most of the kind of information that you've gathered during the day. So it's put up here as an example, not of learning, but of model selection in making you more or less curious. But I repeat, none of these papers addressed, if you like, manipulating the degree of curiosity through the various precisions. Interestingly, from your point of view, to simulate different precisions that would lead to parametric learning, or differences in parametric learning and or structure learning that underwrite curiosity, is actually very, very simple to do, in the sense that in these models you basically accumulate Dirichlet counts that score the number of times that something has happened or a number of associations have been experienced, and then you renormalize the Dirichlet counts to give you the likelihood that this will happen if that happened. And you can see immediately, if you start off just with one observation and then something happens, now you've got two, as opposed to, well, let's start off with, there are two possibilities, and you've got one Dirichlet count, another Dirichlet count for both. So you don't know, it's 50-50. Then you see one thing happening, and then it's 2 to 1. And then you see a third thing happening, it's 3 to 1. What this kind of belief updating, basically learning in this instance, means is, if you started off with 100 and 100 encoding your prior belief that I'm not biased, and then you see one more, and you've got 101 to 100, which means that the likelihood ratio, the 101 to 100, hasn't changed very much. So the way that you equip agents with very, very precise, rigid beliefs is by loading them with lots of prior Dirichlet counts, and then they learn very, very, very slowly, or they accumulate less evidence simply because the precision of their prior beliefs is much bigger than the precision of the sensory evidence, in exactly the way you were talking with Peter about, and we were talking about earlier on. So it's just a really it's a simple way of introducing phenotypic variation between individuals in terms of the precision of their prior beliefs, not about states of affairs, but about contingencies and associations and what would happen if I did that. So I'm hoping that paper goes into that to a certain extent. And this, you were talking about the role of neuromodulators, dopamine, norepinephrine, and cells of origin, the locus coeruleus. And I think that's really very important because neurobiologically speaking, most people believe that precision of beliefs in inference, as opposed to what we're just talking about, which is the precision of the parameters of a generative model, thought to be encoded by synaptic connection strengths, say synaptic tags of the kind modeled by these Dirichlet parameters. In the context of inference, the precision is usually thought to be encoded by synaptic gain, therefore optimizing the precision of any, or the learning rate, if you like, or the sensitivity, corresponds to modulating the postsynaptic gain of various neuronal representations of the Bayesian beliefs, which means you're talking about neuromodulators, and you foregrounded the importance of that, because once you've got a mechanistic explanation of different kinds of personality in terms of differences in the priors over the precision, or the posteriors over the precision, you've now got an account, certainly at the level of inference, that links it immediately to attention and salience, and the ensuing effects on different kinds of behavior. So this is a nice paper by Thomas Parr, who just takes you through, and I think there's a little table. Yeah, it just takes you through a sort of a non-neurochemical expert's view of the neurobiology of precision in terms of its pharmacology and the various neurotransmitter systems that are involved. So I thought that might be a useful summary, just to again demystify or to clarify the very simple link between learning rates, precision, neuromodulation, attention, and so on. The other thing you mentioned, oh, sorry, this is just in the bucket of papers written by other people that you may enjoy reading. This is by Ryan Smith, and I introduce him because he was the author of, I think, one of the tutorials that you referred to, but also he's done a lot of work in terms of the mechanics and building models of emotional inference. And this one, I think, specifically talks about personality. Active inference models do not contradict folk psychology. Sorry, yeah, and this is the second of Thomas's papers. So not only is precision underwriting attention, but also through its manifestation in terms of neuronal gain control, underwrites the movement of both a fine and a coarse kind. And this is a paper that you could use just to join the dots and say, well, if it's all about precision, then not only is it about attention, but it's also should be manifest in terms of motor function. And I'm just wondering what, yeah, so this was actually, yes, looking at reflexes. There is also a literature on saccadic eye movements, but in this instance, Thomas was focusing on fine motor control. The point of just highlighting this paper is to allow you now to, I repeat, join the dots between precision, attention, and motor control, simply because they rest upon the same neurochemical or neuromodulatory or possibly electrophysiological mediators of precision in terms of the brain. This is just for fun. This is you talked a lot about theory of mind and the importance of, and just to acknowledge actually your discussions that just making a good world model and making sense of your world and making the right decisions is only one small part of the story. One has to now think about this in the context of your primary carers, your conspecifics, your classmates, and your colleagues in the society in which we live. So this was a nice treatment by colleagues at Montreal University, applying active inference effectively to quite a high order kind of theory of mind in terms of trying to understand the coupling between an individual and her environment and what that means for inferring another individual or another conspecific, and how one can read that in terms of cultural niche construction. So one just for fun. What's this one? Oh yes, this is by Jeremy Holmes. Do you know Jeremy?
No, I don't actually.
I recommend, and if you'd like, I'll write you a letter. I'm pretty sure it's at UCL. So
Please,
Jeremy Holmes comes from, you'd be a friend of Peter Fonager, I'm sure. So he's written this book, which I think is very pleased with. It's about 3 or 4 years work now, but it's his treatment of attachment theory in the context of psychotherapy. And so not directly about personality, but certainly touching, I'm sure, upon things like epistemic trust and the like, from the point of view of neuropsychoanalysis. So if you like, I'll email Jeremy, or if you email me, say, can you introduce me to Jeremy? I'll respond to Jeremy, and then you can get a free copy of his book. Otherwise, it's 16. No, it's only £10, £11. That's okay. Right. So to conclude, you can go to the SBM website and download the MATLAB scripts that do the demos, then get your PhD student to repurpose the MATLAB code, making a request to people like Thomas or Paul Badcock or Axel for the code they use for their papers, and then repurpose it to make it do what you want to do. Or you can use the PyMDP. So this is just the PyMDP Python version of Active Inference from the GitHub. And I do believe it has some very nice sort of training examples. So it's designed for people who've never done this before. How do I build a model of this paradigm or that paradigm? And then when you've done that, this is the paper that I think Peter was referring to. That you can then, once you've got a model of your favorite paradigm, you can then use it just simply as an observation model in a standard sort of psychophysical, psychological choice behavior paradigm. This actually just showcases now a sort of classical paradigm that was actually built for mice in a maze, but emphasizes the epistemic and the intrinsic motivations of going to get informative cues to resolve your uncertainty about where your goal is. This is he used, or Philippe Schwartenbeck used this to illustrate how you could fit this to observed mouse behavior, for example. But you can generalize this, and people have done now, particularly Ryan Smith in the context of psychiatry and emotion research. You can generalize this to humans. Good, I think that's it. Yes, we finished. Well done. Well, to me for getting through it, and to you for listening.
Well, that was, incredibly useful. I'll be obviously poring over the recording and all the different papers. So this is absolutely fantastic.
Yes, I was not aware of that, specifically the witness parameter, but it does sound absolutely intriguing. One might even argue that if you read the witness as witnessing the degree of entanglement, in classical Bayesian mechanics, that's just a degree of conditional independence or dependence, which would be read as an entropy. And of course, neg entropy is precision. So you could say that the witness parameter is it is a global precision parameter. So that was really interesting. The other,
I sense that discussion is nearing its end. Is that correctly sensed, Carl?
From my side, it could go on forever, but as I said, it is absolutely very generous of all of you and your time. So I don't want to waste any more of it.
Very, very interesting. And I have learned a lot, also just from listening in now.
Thank you.
Okay, then the last thing we'll do is to give you a final round of applause.
Oh, thank you. Thanks.
Thank you for a wonderful presentation, and see you all.
Thank you so much. Thank you.
Bye-bye.
Bye.
Thanks.
Bye, everyone.
Thank you.